Suppose set A contains 20 elements and set B contains 68 elements. If sets A and B have 14 elements in common, what is the total elements in either set A or set B? So where do we begin? I like to start at the very end, namely, I like to look at the question that we're actually being asked. What is the total elements in either set A or B? I emphasize the word or, specifically either or, because in math, when we talk about set theory, or actually represents the union. So when we're asked what is the total elements in either set A or B, we're asked what is the number of elements in the union of the sets A and B. Specifically, what's the cardinality of the union of A union B? All right, so that's what we're looking for. Now let's write down what we know. We know that A contains 20 elements, so I know that the number of elements in set A is 20. I know that B contains 68 elements, so the number of elements in set B is 68. And I also know that A and B have 14 elements in common. And I'm going to circle those key words because A and B have elements in common is a big flag that yells intersection. So that tells me that the number of elements in the intersection of A and B is 14. So let's put all this information together. There's actually two ways that I could look at to solve this problem. One is with a visual Venn diagram, and the other is with the cardinality rule. So let's start with the visual Venn diagram. Venn diagrams come in handy when you have complicated word problems. This one isn't too bad, but we'll start with the Venn diagram. So a Venn diagram, if you recall, consists of a pictorial representation for sets. Namely, it starts with a big rectangle, and inside that rectangle, we draw our sets. So let's take a set A right here, and A is going to be my pink set. And then let's intersect that, or overlap that, with another set B, a green set B. Now what do I know? I know that the number of elements in the pink set is 20. So there's 20 things that are lying in my pink set. I also know that in set B, or the green set, there's 68 elements. So there's 68 elements lying in all of those that green set, that green circle. And finally, I know one more piece to my puzzle, and that is I know my intersection. I know what's going on in the overlap. Specifically, in this part in here where where pink meets green, that's my intersection, and I know there's 14 elements that lie in there. So how do we calculate the total in the union? Well, the total in the union has to be the elements that lie in each separate part in our Venn diagram. We have the elements that are in the middle. So in the middle, there are 14 elements total. We also have elements that lie over here in just the green part. And then we have elements that lie over here in just the pink part. So if we have 14 in the middle, we need to figure out how many are left over in the pink and how many are left over in the green before we can add them together to get the total in the union. So how do we go about getting the elements that are just in the pink portion? Well, we have to take the total elements in the whole pink set, which are 20, and then we have to subtract from 20 the number of elements that are in the middle, the intersection if you like. So if we subtract off 14, that tells us there are 6 elements left on the outside of that intersection, but which lie inside the pink set. So we have 6 elements in the part that just contain the elements in A. Let's do the same thing on the other side with B. On the other side, B, the total number in the green circle is 68. But we're going to subtract off the 14 elements in the middle. That's going to give us that there's 54 elements that lie outside of the intersection, but still inside of B. So here we have 54 elements right here. Now what's my union? My union is everything that's on the outside portion of the pink, the 6 elements that lie just in set A, the 14 elements that lie in the intersection, and the 54 elements that lie in just the portion B. Okay, I don't know about you, but my color scheme is pretty crazy right now. But hopefully you guys can see my numbers, right? So we've got the number of elements in A union B is equal to 6 plus 14 in the middle plus 54 that just lie in B. If I add this all up, that gives me 20 plus 54, or simply 74 elements lie in the union of A and B. Now that was solving the problem with a Venn diagram. If you're good with that and you understand that explanation, you can stop right there. But there is another way, I actually think it's a shortcut method, that will also allow us to get to the same number, but using a different technique. That is something called the Cardinality Rule. And I think Cardinality Rule because the Cardinality Rule involves the union and intersection of 2 sets. Specifically, the Cardinality Rule says that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. So the Cardinality Rule gives us just a different way to solve this same problem. Let's fill in the missing pieces. We're trying to find the number of elements in the union. We start with the number of elements in A, which is given to us and is 20. We add to it the number of elements in B, which is 68. That's also given to us. And then we subtract, based on this rule, the number of elements in the intersection, which we also know, which is 14. So like I said, the Cardinality Rule is specifically good in this type of a problem because we have a union that we're looking for. We know the number in our first set, we know the number in our second set, and we know the number in our intersection. So it just beautifully fits into our Cardinality Rule, makes a nice sweet algebraic equation, or simply expression if you think about it. We have 20 plus 68, which is 88, and 88 minus 14 is simply going to be the same number we got when we did the Venn diagram, and that's 74. It's a little cleaner and a little shorter. Cardinality Rule doesn't work in all situations, but it works very nicely in this specific case. Well, I hope both of those examples or both of those explanations helped you to understand this problem a little better. If you have any questions, don't hesitate to reach out and contact me.